Alright, so we really kind of just went through a problem, but we're going to go through another piecewise. It says find f of 1. So in this case, f of 1 would be where it's a closed circle. But, exactly, first, two of them. So, exactly, it would be equal to both. It's not a function. Don't say it's a function. That just means, like, equation. Okay. And then for the next part, it says the limit as x approaches 1 from the right. So we're going to trace our graph from the right. And we get then the limit as x approaches 1 from the left. And the limit as x approaches 1. So nice. She realized I didn't want to. Alright, so what I did is I gave you some hints and tricks for finding limits. So sometimes when you look at a limit, you're like, what do I do? And these are sort of the steps I go through as I look at them. First, you always just want to substitute in. Just want to try plugging in the numbers. Next, if you substitute and you get 0 over 0, simplify. So use factoring and substitute for x after you simplify through factoring. Another way we can simplify is doing the complex conjugate. So we're going to do another example of that. And the third way we can simplify is rationalizing the denominator by getting common fractions. Okay, if you get 0 in the numerator and denominator, we know that there is a limit you have to keep trying. If you get a number for the numerator and a 0 in the denominator, then there is no limit. So that's what we had happen the other day. We got a number over 0, and that's when there is no limit. That's the undefined aspect. Yes, you could write undefined. I look into the does not exist. For certain it's undefined. Yeah, like that's what I mean. Like I'm not sure if it would matter at the end of the day. Like if it was a free response question. Number 1 then. That's a polynomial function. It's a quadratic. Quadratics are continuous. Continuous functions limits will equal their function value. So you're just going to plug in 5. And assume this would be a non-calculator question, so you would do your math by hand. So you have 50 minus 15. So 50 minus 15 is 35. Add 4. 139. And limit as x approaches -2. Guys, not gonna lie, sometimes just low-key plug it into the denominator real quick to see if it works. And if it does, then I'm like, okay, I can plug it into the whole thing. If I get a 0 in the denominator, then I go and plug it into the numerator. So 3 times 2 in my mind is 6. I'm like, oh yeah, I'm happy, it works. So we're just gonna plug it in. All right, negative 2 cubed, don't go for the track, that's negative 8. 3 squared is 9, 9 times 2 is 18. These are really hard to write because like my plus and minus is keep looking. Erase. No, d part plus 6, it's 11. So it's negative 111. So I can only bring like that. Oh, Grace, is that how you write it? Holy moly.
The pinky
The pasty is underneath it. And then the top is on top. That's okay. Alright guys, 1 minus 1, 1 minus 1, what do we get? Okay, what's x squared minus 1? Yeah, it's a difference of squares. I think I could write that off my left hand. So x minus 1, x minus 1. Cancel. Yeah, now, what I want you to take note of is until I plug in the 1 for my limit, I always write the limit. Because just like a function, until you actually plug in the number, you haven't done the operation. The limit as x approaches 1 is an operation. It's like kind of like saying something squared. It's like part of our PEMDAS order of operations. So until I plug the 1 in, I write my limit. So if you plugged it in at the very beginning, exactly, minus 1, 1 minus 1. So that told me I needed to factor. So I did, I just didn't write it down. It hurts my little pinky.
Wait, but I saw you were kind of just like writing like this. You gotta let it loose and then shoot.
Okay, I was holding it like a fist.
Yeah.
The problem is on the board, I can't drag my hand. Like I could try it on a whiteboard, but like on here, if I drag my hand, it'll double. Like it will like, or sometimes like I get like it's double rates. Stop yelling at me. What's the next question? Because it changed pages on me and I didn't need for it to. And now I think this is going to be yellow. Oh my gosh. Alright. What is the complex conjugate for this problem? Because once again, you automatically know when you plug that in, what's going to happen to your denominator. Yeah. And then 3 plus 0 is going to do what? Give you 9. 9 squared, or 3 squared is 9. 9 minus 9 is. Okay, so how can I clean this up or manipulate this algebraically? Yeah, not factor, like So technically, like, you could have equal signs at the ends of all those, plug in your zero, and then it is. It is. It's actually also the definition of the derivative. Zero plus 9 is 9, square root of 9 is 3, 3 minus 3 is 0 squared is what? It's a difference of squares with a complex conjugate. I never know how to make this great things. When you write the plus sign right now, so if you multiply by the complex conjugate, so the complex conjugate is the difference of squares made. Like, that's why I was trying to explain, like, you're really doing a difference of squares because you want to end up with the first term squared minus the last term squared. That's what you're going to end up with. And if you think about squaring a square root, cancels. So you actually don't, if you can just memorize that you're setting up a difference of squares, then you're just taking the original first number squared minus the last original number squared. Every time. Never, ever mess with your denominator. What? Ever mess with your denominator. Unless you can cancel the numerator, we always keep the denominator what it is. So you get t squared plus 9 squared the first term minus the last term squared, so 3 squared is 9, over t squared times the complex conjugate squared, t squared plus 9 plus 3. Go for it. A squared minus b squared. And a negative 3 times a positive 3 is a done. The only way I know how to fix it is from that. Oh, it doesn't even look like that back here. I can move it. So again, positive 9, negative 9 cancel. T squared over t squared also cancels. But what is 5 divided by 5? T squared divided by t squared is, yeah, so your numerator doesn't go away, it becomes a 1. Because the limit as t approaches 0 of 1 over the square root of t squared plus 9 plus 3. Now we plug in 0 for t. It is. it's really every year I go, welcome to algebra with a little bit of calc. Like a lot of calc is a lot of algebra.
Oh, I'm not.
Okay. I can give you the notes. I already have the all day. I'm excited.
Well, you know. Listen, I know now I'm not making it because the cutoff's 85. However, it's a free day out of school. Wrong.
Alright, so we have x over x minus 4, or x times x minus 4 over our denominator factored. So that's going to be a negative 4 and a positive 1. Yes. So you have x minus 4 and x minus 4 to cancel. So when you cancel those factors, that's called removable discontinuity. That's like last year, it would give you a hole on your graph. So if you remember talking about where is there a hole on the graph, the hole is at x equals 4. That's why this graph technically doesn't have a value at x equals 4, but it has a limit because it has a hole. So the limit as x approaches 4 of x over x plus 1 is equal to the limit for that, which is equal to 4 over 4 plus 1, or 4/5. Yes. You have to get a common denominator so you can group your fractions together. Okay, so my least common denominator. So this is like t times t plus 1. So then you need a t plus 1 over here. So they have an LCD of t squared plus t, or t times t plus 1. So you would get the limit as t approaches 0. So you have t plus 1 minus 1 over t times t plus 1. Yep, so the 1's cancel, the t's cancel, and this becomes the limit as t approaches 0 of 1 over t plus 1. Plug in your 0. And you get 1. Yeah. So positive 1 and negative 1 cancel. And then t over t cancel. Yeah, I agree. That's why you see how I try to like put little leafies under mine? I'm granted my handwriting was ugly because normal teas are way nicer. And FYI, I'm learning a couple other sides. Write them on out of the printer. So like when we used to have to make t-shirts because screen printing wasn't a thing, I used to print them on the printers and then use Sharpies and trace through the t-shirts on my shirts. So I might get t-shirts They're always like really nice looking because I just trace pages on. Yes. Alright, so I have the 3 worksheets for you to work on once graphs. And they're all like little mini puzzles.